All right, so let's go ahead and look at number 6, but you don't have to really do a whole lot with that. I just wanted to go ahead and complete it. We started talking about it on the last one. This problem right here has an exponent that's twice as big as this one, which means it's basically kind of like a quadratic, you know? Like if you had x squared minus 6x plus 5 equals 0, for instance, you would have factored with an x and an x, and I guess a 5 and a 1, both negative. And then you would have gone from there. So like, you don't do that because it's not x squared, but you do something very similar. You do e to the x and e to the x, because if you multiply e to the x and e to the x, you get e to the x plus x, because those, when you're multiplying, the exponents would get added, and then x plus x is 2x. So you can separate it that way, and then you would have minus 5, a minus 1. You would set each of those equal to 0. Okay, and you would add the 5, add the 1, and make sure that x, you're realizing it's still up high. Now at this point, we don't know x is 5, we know e to the x is 5. So now we got to think about how these are exponential. We got to have a way to bring that x down in front, but you shouldn't think that, okay? A lot of students do that, okay? That's not the logic of it all. What you have to do is you have to log both sides, use a logarithm of some sort, and because this is base e, I'm going to use natural log, because it'll save me a step. I'm going to do that on both of these. And if this is natural log and this is base e, I'm just going to have an x left there, and that would give me one exact answer. And then here, these are inverses, so I have just the x left there equal to this exact answer. And then I can do decimal approximations if it wants me to, and I'm going to get about 1.609 on that, and then the natural log of 1 is really 0. Okay? Okay. All right, and then the two problems you see at the bottom, you're going to be doing a little project for me that's going to look like that. It's going to deal with things like that. This is actually, looks like it might be maybe a compound interest problem where you have a 4% interest rate and they're going to calculate the interest 4 times a year. And it's like the question they're asking me is, how long will it take for my $27,000 investment to grow to be $30,000? Okay. You don't need to know what it potentially could be, but I just wanted to share that. All right. So our goal on this one is to try to get the t, that's the variable in the problem, by itself. So we got a whole lot of work we're going to do to get there. Okay. One of the things I'm going to do is clean up the inside here. 0.04 divided by 4 is 0.01. So I really have 1.01 inside there. Okay, with this 27,000. And that's to the 4t power. So I'm working on getting the t by itself. You know, some people really do better when that expression that has the variable in it is on the left. So you may want to at some point interchange the two sides just to make it so that the variable you're trying to get by itself is on the left. People tend to do better when it's like that. So there is times in front of that after that 27,000. And so we can just divide by the 27,000. We have to do it on both sides. Okay. And the reason we're doing that is we need the exponential. We need this right here to be isolated before we go and do any kind of log. Okay. So this would be gone. And that would give us 1.01 raised to the 4t power. And then we would do the 30,000 divided by 27. We could divide out the 1,000, simplify that down to 10 over 9 if we wanted to. And you know, I guess you could divide 10 by 9, but you know, if you do that, it's going to mean that you're going to round, because that's like 1.11111 keeps going. So I don't know, maybe I should just leave it a fraction. It's not that much harder. All right, so at that point, the exponential part's by itself. So now you're ready to come in and log, and you could log or natural log, doesn't matter. on both sides. Oops, can't do one on one side and something else on the other. Got to do the same thing on both sides. All right, and then the exponent can be brought down in front. That's that property 3. It allows you to do that, and it leaves you just with log of 1.01 there. And then you over here have the log of 10/9 sitting there. All right, now at this point, I'm trying to refocus, trying to get t by itself. There's 2 things being multiplied by it, so let's divide by those on both sides. And so that leaves you the t equals the log of 10/9, which is really 1.111111, keeps going. I could say log of 10 minus log of 9, but anyway, you don't need to do that. Okay. All right, now that's the exact answer. If they wanted an exact answer, that's it. If they want an approximation for that, you have got to try this on your calculator. You're going to mess up if you don't practice plugging it in, okay? And I don't want you to mess up when it comes time for the test. Problem is, this is a grouping symbol, so that has to be in parentheses. So when you enter it, it'd be log of 10/9, and then you're divided by, and then parenthesis 4 log 1.01, close it, okay? All right, and so that turns out to be, that wasn't yet rounded. I didn't round yet. I just showed you how to enter it. That still equals. And then that turns out to be about 2.647. Okay. So please concentrate as you're going through the notes. Work on trying to understand the process, not just memorize how it looks at the end. Really helps you make sense of it. All right, here's another modeling problem, okay, that you might see. And this is actually a half-life problem, because this is how much of a quantity I started with, and the question really is, how long does it take to get to half of what it was? So this actually has a negative, which causes it to be a decay problem. There's a whole lot of cool stuff you can talk about with exponential functions. Unfortunately, they're always at the very end of a pre-calculus class, so it's hard to spend adequate time on it. Okay. All right, so we're trying to solve for t. I just moved it around so the t is on the left-hand side. So what I'm going to do is get rid of the 500 so I can isolate the exponential and see why these are called half-life problems when you do that. Okay, I wanted that in blue. Now my pretty colors are messed up. Oh well. Okay, then this is going to be e, okay, to the negative 0.032t equals 1/2. So the exponential part is isolated. So now I'm going to come in and I'm going to use natural log. Since that was base e exponential, use natural log. Whatever you do to one side, you got to do to the other. Okay. All right, so the natural log and this being base e, those are going to undo each other. You're going to have negative 0.032t equals the natural log of, and I can go ahead and change that into a decimal. I didn't do that here because 10/9 is 1.1111, keeps going, but 1/2 is just 0.5, okay? So now I'm just needing to divide by negative 0.032 on both sides, negative 0.032, and my t exact answer would be the natural log of 0.5 divided by negative 0.032. And then I'm going to type that in, and I'm going to get about 21.661. Okay, so that's the end of exponential equation. So I'm going to stop sharing on that one.